A very good afternoon, dear participants. I'm Reema Joshi, Faculty, Department of Computer Applications, St. Edmund's College. On behalf of the organizing committee, I would like to warmly welcome each one of you to this webinar on Introduction to Internet of Things and its Applications. The field of IoT has sparked a global revolution and has found place in almost every sphere imaginable, from home automation to healthcare to manufacturing systems. Today's sessions will unravel the wonders of this sought after field, and so thank you for choosing to be a part of this learning experience. And we sincerely hope that you will enjoy the sessions and feel enriched at the end of this webinar. As informed earlier, the webinar has been divided into two sessions, the first on YouTube and the second on Google Meet. The first session comprises of the inaugural and the speaker's address. We will now begin the inaugural session with a welcome address by our respected principal, Dr. Sylvanus Lamare, followed by an invocation prayer by the Dean, Dr. Mrs. B. Nongbree, and then a special address by the head of the department, Mrs. Sarmistha Deb. Thank you.
Greetings from St. Edmund's College. I'm very happy that the Department of Bachelor of Computer Application is organizing this webinar on a very important topic of today, that is Introduction to Internet of Things and its applications. Friends, we are very happy to have as a resource person Mr. Praveen Kumar, founder and CEO of Ekkaga Technologies Private Limited. Sir, you are welcome to this webinar, and we hope that we will be inspired by you in the use of Internet of Things and its application in our daily life. Today, the 29th of August 2020, is the day when as a college we celebrate Founders Day. That is the death anniversary of the founder of the Congregation of Christian Brothers, Blessed Edmund Ignatius Rice, an Irishman who thought of starting a school for the poor people of Ireland in his time. St. Edmund's has been blessed with great principle and with great ideas. And one of such principle is Brother Chanu, who thought of opening the Department of Electronics as early as 1981. And today, perhaps in Eastern India, St. Edmund's College is the only college that has a Department of Electronics, which is vibrant and which has produced a number of people who have contributed towards knowledge. We were also the first college to start computer science, and of course, one of the first college to start Bachelor of Computer Application. Today, as we prepare ourselves to listen to Mr. Praveen Kumar on a very important topic and in a very important subject, that is the use of technologies in our daily life. It is important for us to realize that today we depend so much on internet, we depend so much on computer, and we depend so much on software programming and hardware definitely. This webinar is not only for the students and faculty of St. Edmund's College, but it is also open to students of other colleges and staff of other colleges. We wish all the best as you listen to Mr. Praveen Kumar. My dear young friends, the students of St. Edmund's College and the students of other colleges, in your hand you have a smartphone. Make sure that that phone that you have is smarter than you. Use all its application to benefit yourself, to benefit the society, and to benefit the people that are around you. I'm very happy that the Department of Bachelor of Computer Application, under the leadership of Professor Sarmistha Deb, has taken this initiative. And I hope that this initiative that you have taken, along with the members of your department, will take a long way and will also inspire students of this Internet of Things, the most important thing that is happening today in technology. I wish all of you all the best, and I hope that as you listen to Mr. Praveen Kumar, you will be inspired, you will take up ideas, and you will challenge yourself to be contributors towards building of knowledge in the society and also contributors to new initiatives that will be taken by you for the benefit of the people around you and for the benefit of the society. I wish the webinar all the best, and I hope that all of us will benefit out of this webinar, that is Introduction to Internet of Things and its application. God bless each one of you, and we hope that we will go much more learned from this webinar. Thank you.
Let us pray. O God, our Heavenly Father, Saint Edmund's College Shillong comes before your divine presence to submit into your loving hands this webinar program, an introduction to the Internet of Things and its applications, organized by the Department of Computer Applications. We bow before you, O God, who is omnipotent, omniscient, and omnipresent. The head of the department, Mr. Deb, and a team of teachers have diligently planned this program, but we pray that you, O God, will bring it to perfection. We pray for the speaker, Mr. Praveen Kumar, founder and CEO of Ekkaga Technologies, that you give him the needed wisdom. We pray for all the participants and for all the interactions that follow. We pray that this program will bring effective results because our aim is to build and to edify one another. Amen.
Respected Principal Dr. Silvana Slamare, IQC Coordinator Brother Simon Coelho, Dean Dr. Mrs. B.W. Nongri, dear participants and my fellow colleagues, a very good afternoon. It gives me an immense pleasure to welcome you all to this inter-college webinar organized by the Department of Computer Applications, St. Edmund's College. 30 years ago, the idea of connecting everything was just a topic of fiction. But with introduction and technological advancements and introduction to the internet, the fiction has become reality. If I had to define today's generation, I would say today's generation is the mixture of hardware, software, data, and services. Today's talk will focus on one of the absolutely critical aspects of our day-to-day life with technology within the IoT environment. Our requirements regarding technology, reliability, and standards will be reviewed, and some conjectures will be given on where advanced communications in the field of IoT lies in the future. It's a great privilege for me to introduce our guest speaker, Mr. Praveen Kumar, today, who has in the depth knowledge and years of experience in the field of IoT. With great pride and honor, I, on behalf of the Department of Computer Applications, St. Edmund's College, heartily welcome and request him to give all our participants an insight of how versatile, vast, meticulous the field of IoT is and how the future of IoT is going to be. With this, I would like to set the second session open to all. Thank you.
Dear participants, we will now move on to the second part of this session where the speaker will deliver his talk on Introduction to Internet of Things and its Applications. Let me introduce to you the speaker for this webinar, Mr. Praveen Kumar, founder and CEO, Ekkaga Technologies and Services Private Limited, Bangalore. Mr. Praveen Kumar is a technical leader with 15 years of experience in the fields of IoT, mobile, telecom, and e commerce industries. He has over 7 years of leadership experience in research and development, software development, and team management. He has built automotive IoT products and is working on smart home solution. Mr. Praveen has designed and developed Nokia X SDK, during the period of which he played the role of lead engineer and architect for Nokia X SDK. He has also managed e-periodical content team as a software development manager to handle an 8 plus people engineering team for high user and high volume content delivery to Kindle devices. Mr. Praveen has played various roles in Agile like Scrum Master and Product Owner for Nokia. These are some achievements of our speaker. Mr. Praveen Kumar has built a 25-member team at Ekkaga Technologies from scratch. He has various kudos to his credit for Nokia X SDK and Mega Operator work. He has built an 8 plus member strong team for Amazon in a record of 3 months. Mr. Praveen also has various kudos and awards for helping team members and learning sessions. He is among the top 10 performers of the C++ programming event in Nokia and is a certified Scrum Master. Let us now hear from Mr. Praveen Kumar about Internet of Things and its applications.
Hello everyone. I'm going to take a session on Internet of Things and its application. In next 1.5 hours, we will be discussing about the various basics aspect of the Internet of Things, but the agenda will cover these topics in details. What is an IoT? The key components and the elements of IoT platform. We'll discuss about the various components and the architecture of IoT, followed by the protocol for Internet of Things. We will not have too much details about it, but we'll cover the basics of data analytics for the Internet of Things. We will look at some of the use cases and the application of IoT. Then finally, if time permits, we will discuss about the skill required to develop an IoT solution. We will spare some time for question and feedback. So let's get started. So before going to Internet of Things, very first question comes to your mind: what is things, right? So things are nothing but the smart object. What do you mean by a smart object? The object is capable of sensing, or let's say sending the data to the platform, to the internet, and we can especially think this as a smart device or a smart object which is capable and can be uniquely identified. So some of the example which you can refer as like car could be your smart vehicle, which can be a thing which can emit a lot of data about yourself. For example, the speed of car, the car RPM, the car clutch, the fuel consumption, the fuel level, and so on. Similarly, like we all are familiar with laptop, PC, mobile phones, a smart camera, and so on. All of these are smart, and all of these are things which is making the Internet of Things a reality. So what do you mean by reality is that we will look into it in details. But if you primarily look at what is Internet of Things, so Internet of Things is nothing but as a network of physical devices, could be vehicle, could be home appliances, could be any other embedded smart object with electronic software, sensor, actuators, and connectivity, which enable these objects to connect and exchange data. So Internet of Things, look at the picture on the right hand side. What we have seen already is that the home has become smart, the connected home, If you look at your dress, that could also become very smart. You look at your uh, body, could also be very smart, and so on. So some of the key points about the Internet of Things. So first of all, the Internet of Things was coined by Calvin Aston of Procter and Gamble's. After that, the various projects on which the Internet of Things were used. So one of the early adopters were MIT's, where 1999 the IoT emerged. So there are a huge number of devices which are already uh, are on Internet of Things, but at the year 2020, at this year, it is expected to be 30 billions, even more than that. And the businesses are growing. I'm saying, like, the global market of Internet of Things has increased to 7.1 trillion by this year, and the numbers are growing. It's growing much faster than expected. The pandemic, or let's say the current COVID-19, has certainly impacted Internet of Things deployment, at least in a country like India. But it is other side. It has also become an opportunity where the automation or Internet of Things is helping to remove the problem of various factory, farm field, smart cities, and so on. We'll discuss about some of those towards the end of the session, when we will be covering about the application of Internet of Things. Primarily, if you look at the number of the connected objects, has already passed the human population in year 2010, and right now it is going many-fold. Okay, so what we'll do, we'll play a small video. This video will give you a quick overview of Internet of Things, and then we will resume it after that.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty. that the correct replacement part is ordered and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
Okay, so see, what you have seen over here is that how the Internet of Things is helping the customer, the manufacturer, the service center, the citizen, and everybody, right? So Internet of Things is basically impacting every aspects of our life. So we'll look into the more details down the line. So very first takeaway, what you see up to the slide is the goal of IoT. So the goal of IoT is to connect the unconnected. The things which are not joined or which are not connected to the network will be connected so that they can communicate and interact with people and the other objects or things. Okay, let's move on. So now we'll talk about the key components. Of course, I'm not going to cover the IoT platform now. We'll cover up after the key components. So let's look at what are the key components. The very first key components or enablers are the sensor. The sensor are the let's say embedded devices or embedded system which basically sense a particular attributes. We'll discuss about it. Then we have a miniature computer or system through which can play a role of gateway. We'll discuss that as well. Then the connectivity is very important in the IoT system, where like it need to be taken extra care. Low power is also one of the key establishment or let's say one of the key constraint, you can say, in the IoT. Capable mobile devices is also one of the factor where you need not to go to any machine to look at the current state of device or to issue a command. You should be able to do it with help of your capable devices. And the power of cloud. So the cloud is certainly an enabler where like you are storing all of the data. So there are n number of sensors. Some of them I have just noted it over here. For example, temperature sensor, humidity, accelerometer, proximeter, proximity sensor, motion detector, gyroscope, IR sensor, and so on. System, these systems or the gateway in the architecture we'll discuss. These are like a miniature system which should able to compute certain algorithm, and same time should have capability to communicate with the platform via various available communication protocols. We'll also discuss about the protocols down the line, but some of the examples, if you look at, you may be familiar with as Arduino, Zenino, the Raspberry Pi, Beagle boards, and then of course TX1, TX2 kind of machine. Various other sensor like image sensor, humidity sensor, optical sensor, pressure, chemical sensor. There is a number of sensor. In connectivity, it's again a huge area, but I'm just covering some of the basic thing. Of course, so this connectivity, there are 3 layers of connectivity which is required. In the detailed architecture of IoT, we'll discuss that, but just assume that we are now talking about the connectivity from the gateway and to the sensors. So these are like RFID, there are 3G, GSM, 4G LTE, Wi-Fi, Bluetooth technology, infrared, Zigbee are there. In cloud, there are various cloud, there are various guys who provide cloud as a service, means there is a already IoT solution, or let's say services are provided. In addition to that, there is a raw cloud also, where you can host and you can develop your own application on top of it. So let's move on. So finally, if you look at, this is a summary of a slide which basically represent everything about Internet of Things. What do you mean by everything? In the sense, first of all, you need a sensor, but before that sensor starts sensing, you need to identify them uniquely. So there is identification which is required. Then it must be performing some action to sense. It can sense temperature data, it can sense let's say humidity, it can sense for example the level of water, it can sense, let's say, gases and so on. Then we need certain communication technologies to basically communicate with the system to the IoT platform, which is a cloud, and that can be done with help of Zigbee, LoRa. There is a LTE, Wi-Fi, there is a wired network, and so on. Again, it's a vast area. We'll discuss that little bit in the next session. Communication. After that, there is a computation. The data which has come from n number of sensors that need to be analyzed, or that need to be processed in order to derive some conclusion out of it. So the computation is one of the key aspect of the IoT element. Once this computation and things happen, there are beautiful applications that can be written and can be provided as a service to the end user. Let's look at the case of the vehicle, where like the driver or the owner can get a quick insight about the various issues, or let's say various service which is required in a specific car, because based on the all the sensor update, the systems would able to decide that which component is working fine. Let's, for example, if the tire pressure of a vehicle is low compared to what supposed to be, in that case that basically it will indicate that okay, you need there is a tension and you need to fill the air in your specific tire, right? So these are like part of it. But finally, if you look at, if all of these things happen, very beautiful semantics data evolves, and that we will not be going to discuss in this session, but just for your understanding, this slide summarize this. Now what do you mean by identification? So like you should able to address it. So there's a lot of complexity will come into addressing it. It could be IPv4, IPv6, and so on. Security and privacy is the other important requirement for the IoT, due to the inherent heterogeneity of the Internet of Connected Objects and the ability to monitor and control the physical object. So if you look at your office environment, look at your college environment, look at any well-established environment where like you have well-defined topology, architecture, and so on, where you have a server, and then you have a host machine, and then you have a laptop, but the architecture is well defined and it is not too much heterogeneity into the system, right? So that's the reason it is more easy for you to apply certain logics, rules on top of it. But this is not the case of case of Internet of Things, because let's say the node which are far from the your cloud could be in a remote location that may be not having enough 3G network. They may be using 2G, or let's think like they may be using a different technology to talk between the gateway and to the sensor. It could be Zigbee, it could be Bluetooth as well, and so on. So the challenges are manifold, and some of these challenges we will cover up in one or two slides during the subsequent sessions. So finally, what is called ABCD of the IoT? So ABCD is like there is something could be a smart application that you can build on top of the IoT platform. What you need a connection and connectivity. There are various connectivity. If you see the screen over here, we talk about various things. Then what you do is like big data and algorithm and analytics you bring, so that you make more robust solution which user can use it and can get benefit out of it. Of course, their devices are involved in any of the IoT solution. You need to manage them, or let's say take a decision which is the right device or not. So this is the other section that need to be done. So on the risk side of IoT, not the must thing in this session, but I will cover it down the line when we will go through the IoT architecture. Then we will cover up some of the IoT risk. Okay, so it is like the various challenges are there in IoT, but some of the key challenges are like how to do a access control. There's a compromised devices into the network, then how will you block them? There is a weak and hard coded credentials could be a threat. Difficulties to update firmware. Let's say for example, if all of your devices are remotely in your hand, and the releases are happening from, let's say, cities like Bangalore, and there is no connectivity, or there could be some authentication issue. In that case, you will see that the firmware is not being upgraded. If there is some security or OS loopholes are there, that is still continuing. So that is another issue that we see. Lack of vendor support for repairing, because there is every IoT solution provider, they have their own set of IoT platform, nomenclature, the networks, the way of working. Of course, there are certain efforts are being put in order to synchronize them, in order to bring into like one kind of protocol, one kind of talking and so on, but still like things are not in a very good shape where it should work across the system. Yeah, so as embedded system, a lot of time there is a code issue also occurs. Sometimes there's a lot of DDoS attack happen. Physical theft and tampering is again a very big risk out of it. So I think by this we have completed the first section. We call it, let's say, very basics of IoT, and then what we will cover up now as a IoT architecture. So give me a minute. I will be just continuing it in a minute. Okay, so let's start with the IoT architecture. So IoT architecture, of course, there are various form of IoT architecture, and like there are a lot of variation which you can look at it. But in nutshell, if you see, these are the prime different groups or categories of the IoT architecture or IoT platform per se. So very first thing is things or devices, as we discussed in the introductory part, right? That these devices are capable to sense, right? And then we have a capable gateways. That gateways are capable to talk to the IoT platform, and the IoT platform is capable to process or handle in huge amount of devices or the gateways or the sensor, and same time they will able to process all of these data. And then finally there are a lot of ERPs, or let's say the enterprise level solution on which this platform should be integrated, and finally you get a very interesting application out of it. So if you look at this slide, also cover up, I will try to point out the different issues. For example, look at this area where there is a communication happening between the things and the gateway. So this is one of the area where need to be secured. Okay, this is mostly happen wirelessly, but yeah, there's a wired possibilities are there. For example, if you look at the industrial IoT where Modbus are used, and the Modbuses are nothing but they are physically connected all the components or the sensors through a central gateway using a wire, right? So in case of car, it could be wireless, it could be various other new coming protocols. Then the second communication requirement is the gateway talking to the platform, where you need a internet connectivity, and then only you will see the smartness of your system, where the platform is capable to take a decision on behalf of the whole system, and can help the customers or can give them the benefits of IoT. Okay, so this is the second, where the large range communication. What are the more evident and prominent kind of protocols? So one of them are certainly the Wi-Fi, through which, let's say, you are connected with a router, and then router is connected to the service provider, could be Airtel, Jio, or Vodafone, and so on. There could be like some of the other thing could also use LTE kind of thing. Some of them can use Ethernet, and so on. And finally, the IoT platform and the enterprise, they are certainly connected using a much better network, using cloud, where like they have either socket or TCP, UDP, REST kind of communication. The usefulness of all of this is only once you have a very good application on top of your platform, right? So this is again done with the help of REST base is typically there, but yeah, MQTT and other part are there. So one of the challenges what we see in this whole IoT platform is the secure communication at all the layers, right? So in the security section we will look into it. Now if you look at primarily the IoT components looks more or less a kind of this one, where the central area is nothing but the bold verticals line inside it. So the security is one of the important aspect. There's device registry, where like you are registering the device, you are managing them, the data which is coming, you are storing them, taking certain decision on top of it. Event management, analytics, and UI is another area. And then finally the application enablement. The application enablement is nothing but allowing or let's say enabling third party to develop application on top of IoT platform, right? On the left hand side, if you look at the connected devices are nothing but the things, where like you have the devices, then there is a gateway. The gateway is basically working as a aggregator for all the connected devices or sensor, and sending the data collectively using some connectivity to the platform, right? On the right hand side, if you see, there is a API which basically is extending this platform, where you can write mobile application, you can write web based application, and so on. We will just show a small a quick example. Let's look at there is a guys who will come to the platform, they will register, then you got a smart plug, look at the smart plug got some onboarded, usually will register it. After registering, device will start sending data to the platform via well-defined endpoint and API. So this basically will flow to gateway will pass using connectivity to the device data management. The data management will store it. Finally the status can be seen using the GUI which is present on the mobile application. So this is the way you can see the status, and then you should also able to turn this smart plug on and off by using the provided option. So what will happen in that case, the command will come from the mobile, it will via API it will reach to the system, and then finally it will go to the gateway, and gateway will deliver it to the connected devices. Again connected devices will acknowledge it, and finally your system will get triggered, and then your status of that smart plug become on or off based on the command which you have issued. So this is very nutshell. This is the kind of flow that will happen. Now we will cover up the key components about the IoT platform. So this one slide basically again summarize the most of the components. It is which is basically present in the previous slide. The first thing is the thing in the sense anything which can sense data or which is smart in nature is a thing. That thing need to be connected to a gateway. And what is the gateway? So gateway is a guy who works as a bridge between the things and the platform. And what is the platform? So platform can have very extended view, but what I have tried to show into the picture is some of the key components. So some of the key components are there's some terms that we are using as a MQTT broker that we'll discuss little bit more details. And then after the central unit, which we call it IoT platform, the platform can provides an API which can be consumed by the mobile application or can be consumed by a browser. Similarly, if you see there are APIs or there are connectors available through which you can take the data out from the IoT platform to a CRM or to a billing or to an enterprise solution, and vice versa. Through the enterprise solution you may get that data back to the IoT platform. So in nutshell, if you see this picture summarize the different component. If you look at on the right hand side, I have shown S3 or the object storage, video, etc. The nature of the data which is acquired or which is basically sensed into the IoT is two different. So one of them is nothing but we call them as an IoT let's say sensor data, which could be very small, a small packet of let's say temperature or let's say certain parameters of certain electrical pump or industrial piece. Similarly, there's other set of data which is huge in terms of volume. It could be let's say smart camera recording let's say 24/7 recording of your home, recording of your office. It could be public area which is monitored via the help of this camera, right? So those kind of the large kind of the data that cannot be stored into a DB. So for that there is S3 object, but the rest of the data can stay. Now there is a processing pipeline. The processing pipeline in the sense the time when the data is coming into the memory, we can write certain logics on top of it. We'll discuss about some of these rules and smart rules down the line. And there's an analytics pipeline is there where you can process things. Of course there are a lot of visualization tool, there's a reporting, graphs and other thing which is present in the platform which can help you to do it, right? But again I would like to cover it here. Basically 4 segment out of it. One is the device management inside the platform, application enablement platform, and then there are 2 more things which I would like to cover up as application protocol and the data analytics for it. So device management, just think about device management is a component or is a sub component of an IoT platform, which is basically which allows you or enables you to manage your devices, onboard them, monitor them, configure them, provision them. Let's say in case of faulty, you can remove them, backlist them, and so on. So this is again very vast or let's say very big in terms of the whole architecture, but for understanding, think about these are nothing but keeping a housekeeping and book recording of all the devices, where they are, what they are doing, what is the status they are, and so on. Okay, very key important thing about IoT platform is that how easy or how smooth to develop an application on an IoT platform. So AEP is nothing but it is more called application enablement platform, which basically allow any third party solution provider to write a solution on top of a platform. So just to give you understanding about the platform, think about all of you or most of us, we are using Android phone, and we have Android SDK to develop an application. We don't require a phone. We can just develop the solution. We can write a very beautiful application, and then we can upload it to the Play Store, and then whoever wants that application can be downloaded and can give you a good insight about it. So that is, just think, that piece of development which is very smooth and easy is nothing but AEP platform. It is easy to develop, it is easy to learn, it is easy to deploy, and so on. So the most of the platform, they provide some mechanism to perform AEP, but those who provides more beautiful, or let's say more ease to use development kind of thing, they survive longer, and or those, they are getting more customer nowadays. So AEP, again, there's a lot of things inside AEP. I'm not going to cover up all of these as of today, but let's say very key important aspect is the well-defined architecture, nice document with an API. There's SDK that can be integrated into the smart object or into the gateway, and then it should have a very scalable or efficient data management capabilities, right? So there are various things, for example, multi-tenancy, multiple users, multiple subsystems handling, another thing that we will discuss later on. So yeah, so one of the example, if you look at over here, we are again talking about the vehicle management thing. There could be smart home, there could be ATM facility management, and so on. So application enablement platform certainly provides you all of these capabilities, where you should able to write application on any of these verticals, right? So anyway, I think if time permits, we'll cover up some of these aspect. So with this, I will just wait for a minute, and then I will start the activity. Okay, so now we'll discuss about the different protocols which are being used into the IoT solution, and the motivation for understanding this is primarily because the environment on which IoT solutions are written is much different than the normal environment where we have the good infrastructure. Let's consider a smart building, or a college, or any industry where you have a good setup of the network, but when you write this IoT application, the edge or the devices or the gateways, they may be far from the better infrastructure. So that is the motivation to understand and tweak the different protocols. So as you know that majorly TCP and UDP is the two ways which the applications are written in the traditional system. These have certain overheads, and the assumption is that the server and the client both are having very similar kind of setup. Let's understand in your networks lab, if two of your servers are talking, they are properly connected into some wired connection, and then they have a good connectivity, intranet or internet, in order to communicate. But think about your campus. Let's say your campus is spreaded into like a geographic location where some of these nodes which is gathering the sensory information is not very well connected. So that is the motivation. There is a lot more that can be discussed in this topic, but just for understanding that most of the optimization done in both of these, where the implementer has tried to reduce the payload or the overhead of the data transfer. Look at, for example, if you want to send a message to turn a light on or to turn a light off, you just need one bit of information, but still you have to pack them into a packet and then send over the network, right? So that is the reason this modification has happened. There are some of popular protocols are SCADA. Basically, the SCADA provides, or which is basically used for industrial IoT prior to the implementation of the IoT. That's what I'm trying to tell you, that before IoT, the environment was automation environment, where like this operation technologies were there, and using that all the systems were connected. So there's a wire connection with all of the controller, and then there is a central server through which, let's say, communication was happening. So there are various optimization that has gone through, and the adaptation which has gone through to make it IP based. But very two protocols I would like to talk here in the application layer. So one is COAP and the other one is MQTT. So what is COAP? So if you look at COAP is basically designed for a constraint application, and the name itself is called constraint application protocol. It is designed for simplicity. It's like less overhead and having a multicast support, right? So that is the prime focus of it, and this basically work onto a request response mechanism. It's very simple, lightweighted response request model, where, let's say, client can request for a temperature or, let's say, time from server, and then server will return that data, right? So look, means if you look at it, is a variant of HTTP, where it's a web protocol that runs over the UDP for IoT, and it is very lightweighted in terms of the data overhead. It is used for the document transfer protocol, and it is especially designed for COAP, so the overhead is less. It also, similar to HTTPS, it also supports TLS. You can use COAPS, and then the format is basically the IP address, then port, and then your resources. Based on that, you can access the specific resources. COAP packets are very small in size, and then that is the benefit that is being provided to the customer. Packets are very simple to generate and can be parsed in a place without consuming extra RAM. So the meaning is that it is very, very lightweighted protocol, which basically help to reduce the data transfer between the device, between the node and the IoT platform, or to the gateway. So it is very well designed for constant environment. In the same way, there is another protocol which is quite popular, and then it is used heavily into the IoT solution. As you know that when you write your normal socket programming, where you have client and server, you basically make a connection, establish a socket, and then you transfer your message to the server, and server responds, or, let's say, two-party basically involved into it. MQTT does the same thing, but it is designed as a publish and subscribe model, where let's say the things, or the person, or the resources, basically they subscribe for a topic, and then if there's an update in that topic, if some guys are publishing the result, all of the guys who have subscribed for the specific topic basically get that response. So there is a central guy, we call them as a broker, And what broker does, it basically do a housekeeping of all the guys who have registered for or who have subscribed for specific data, and then the publisher is the guys who are capable to update the data. So based on the topic, let's say publisher publishes that value, and that value is basically passed back to the subscriber. Again, the benefit over here is the smaller payload. The payload size is smaller in case of MQTT, and it is one of the default choice in IoT wherever, let's say, two nodes need to communicate. The beauty over here is that the MQTT broker is designed in such a way that it can also store the state, or let's say it can store the previous command or previous message which is published for particular topic, and then the guys who have subscribed were not available. So in that case, once they come home online, the message will get delivered to it. So if you think, I have just shown a scenario here. There is a car which is basically having a gateway or a controller inside it, and which is connected to the platform. What's happening that it is capable to emit various data. Let's assume that speed is one of them. So it can publish the speed, let's say 100 kilometers for example, and then there are various application that is written, which basically, let's say, visualizer, which is showing you the UI, that what is your current speed. So that will get notified. If you have a mobile phone, that get notified. Even if you can also write certain logics on top of it, that will cover up in the analytics part of it. This is one simple example that how MQTT works. Like there is a cloud, so cloud, the gateway is connected to the MQTT, and the rest guys will be connected over TCP or various other protocols. So simply, let's say on MQTT demonstration can be added. So you can, there is a link that is provided to all of you. Through that link you can download the MQTT and install in your Windows or Linux environment, and then you can follow this step. It is pretty simple. You need to compile, build, download, compile, and then finally build and install the MQTT. So you can start the broker, and then you can create a topic. For example, we are creating a test topic, and then from other machine or other terminal on your same machine, you can put publish with the same topic. That message will appear into the first terminal. When you are doing the same call from let's say your own network, then you have to also put the host name, or let's say the server IP address or the name, so that remotely you should also able to publish it. Okay, so these are, like, as we discussed, these are like quite useful, and it is heavily used into this IoT solution. So what I will request that at least you people should try out writing one small message application where you publish a message using MQTT publisher, and then you subscribe for that topic and see that message coming into that. You if you wish, you can also write an application using C where you can develop very similar what MQTT is doing through a client server socket programming. Okay, so now we will move into the data analytics. Again, what I'm trying to tell you that data analytics is a very vast area. It's itself a week workshop generally people conduct on the data analytics. But what I'm trying to give you is a quick overview that what is data analytics, what are the cases of the data analytics which is used in the IoT, and why it is so important. So as all of you know, nowadays data analytics, machine learning, AI, all of these are big buzz, and then everybody is running behind it. So data analytics is a process which is used to examine big and small data set with a varying data properties and extract a meaningful conclusion from these data set. This conclusion can help you, let's say, generally can give you some trend, some pattern, statistics, right? It can help you to take certain decision. It can help you to like grow your business. So what we're talking about, let's look at, for example, if we see the if we have industry, let's say industry could be like we have a manufacturing of biscuit, for example, right? And we have all of our machine connected to internet through, let's say, PLCs or different controller. We can analyze the behavior, and we can certainly save lot of data, lot of money, based on the pattern of the uses of, let's say, our equipment. First of all, what we can say, we can optimize the overall performance or overall equipment effectiveness by looking at the various data. For example, what is the availability of a specific machine, how much time it was down, or let's say when guys went for lunch, the system was running, but there was no input provided, so there is a loss of a specific time, right? So that can be done with help of the analytics. See what I'm trying to do through this slide. I'm just trying to give you a quick overview that what all kind of analytics which is possible in this IoT world, and who all are enabler, right? So very first part of doing any analytics, you require a data, right? What IoT does, IoT provides you a mechanism to gather data with help of embedded system, right? So what kind of data you will gather? So various kind of data you will gather. For example, if you have a device, or if you have a sensor kind of data, a specific device data, there could be certain alerts that is being generated. For example, the temperature is going high for a specific machine. There's a leakage of water at certain places. There could be like vehicle is over speeding. So those are some alerts and events, that kind of data you have. There's a lot of device related health and diagnostic. For example, what is the space left out in the device, what is the let's say RAM availability on the device, and so on. There could be other business application which are connected and which are emitting lot of data, which could be ERP, CRM kind of data. There could be the video being captured into a specific smart home solution, specific to the vehicle, or telemetry solution, and so on. There could be a lot of uses based on data. For example, overall equipment summary could be one of the input. So the data is very important. Once you have a data, and because this is massive data, so I can just give you just a thought. For example, let's consider a autonomous vehicle, where like Google is trying, or let's say Tesla is trying to do autonomous driving. Understand, there's a lot of sensory data that is generated, let's say, in a frequency of millisecond, that need to be analyzed. Without that, you will not be able to take a decision. For example, if your vehicle is going with a speed of, let's say, 100 kilometers or 60 kilometers, and then in front there is a vehicle, you need to apply a brake at same time, right? Or you may have to take a right cut or left cut, and so on. So all of these decisions can be done based on the sensor data, and it's a huge amount of sensor data is being generated. Look at the industrial use case. There's a huge amount of data. All of the sensors are producing with help of PLCs. There's a lot of controllers that are producing, and so on, right? So it is not like a simple data. Let's think like we have our laptop, or let's say system which is 16 GB RAM, 32 GB RAM, and let's say the volume of this data is a terabyte, petabyte, and so on, right? You will not be able to process them, so you need certain tools. So there's a lot of big data analytics based tools are available. I'm not going to cover them, but just think if you want to learn more on that. So the segment could be collecting data, integrating it, there could be processing it, aggregating it, then visualizing it, right? And then finally we will the top rectangle represent the different kind of analytics that is present or that may be useful for the IoT, right? So first is the descriptive, right? What descriptive does, it analyze what's happening in the device, or let's say in the whole IoT solution, right? So you should able to see the you can pull the previous data and look at the behavior of a specific device or a group of devices at certain time. Similarly, there is a diagnostic kind of data. You can look at, you can analyze little more about that, why it has happened, why, what is the reason. Let's say vehicle is down, there could be no fuel, or there could be battery down, or there could be some issues in the engine and so on, right? Predictive is more like what is likely to happen, so you can do some prediction, right? So that you can make certain prediction model based on the let's say the past data, and then learning you can figure it out that okay, what is going to happen if let's say some guy is driving a vehicle always by putting a clutch of let's say a certain point of time, right? So that is the next set of analytics, that predictive analytics happen. uh, then there is a prescriptive where you can prescribe that okay, what the businesses should do. For example, based on all the data of various devices and the industrial IoT data which is coming for a organization, they can look at it and they can say that okay, so generally let's say during the festive season, like the overall usage of the whole system is down to 30%, so it's better to switch off the whole plant rather than running it, right? So there could be various things, I'm just giving an example, and that's the kind of analytics that help the solution on the IoT. Now coming back to the value with the complexity, right? So of course, like descriptive is very simple in nature, where like you can look at it and then you can analyze. Similarly, the if you look at anything which is a prescription which you can predict and you should able to guide the businesses, right? So that is more rewarding. So the complexity and value both of prescriptive analytics is much more. Okay, I have couple of more slides on the analytics, but I'm not going in more details. But very first, but I will cover up, let's say, one or two more slides. So streaming analytics. So what is streaming analytics? So the moment you capture the data and the data is coming to the platform, so there is a real time data streams on which you should process some rule based detection, some urgent situation or the bad condition. So that is known as streaming analytics. For example, it can be demonstrated in fleet management, driver safety, financial transaction, and so on. So let's, I think, for interest of time, I will move. Okay, I will discuss about the time series analytics. So time-based data is again analyzed, right, and then there is a different associated trends and patterns that can be figured it out. For example, weather forecasting could be one, health monitoring, looking on your health. There could be like model which can let the user or the parents know about the health of themselves, that what's happening, that they're keeping good in terms of the BP, sugar, and various other factors, right? So this is kind of analytics that is being used. So anyway, so let's I think we have done closer to the analytics part of it. Now we will move into the next topic, but before that, means we have our own platform for the IoT. We call it Avikshit IoT platform, and this platform, if you means if I think we don't have enough time to discuss it, but in a minute I can just tell you all of the activities that we discuss till now. All of these are present, and a solution can be developed using this, where you need to just only code for the specific use cases on the device side. Rest will be taken care. So I will move on now. As a summary recap of this IoT platform, the below part things basically they use different communication protocol. Of course, they are connected on a constant network connectivity, so they use UAP, MQTT. There are various other protocols that I'm not going to discuss in detail. There is an IoT gateway. Again, this gateway is responsible for aggregating the data coming from the things, and then this gateway passes this data to the platform through either they may have a MQTT connection, HTTP, REST API, or there could be a socket, and then all of these are taken care with a authentication of it. As we discussed about some of the analytics capabilities prior, so this analytics, if you look at the top part in the IoT platform as a in-memory processing, there is some analytics pipeline that occurs. There are certain rules also which you can configure, and based on that it will trigger a message to your configured system, right? Then set of APIs that basically extend the platform where the application can be written, or you can take the data out to the external world and so on. There are a lot of visualization tool, there's a lot of analytics, there is a lot of machine learning, there's a lot of batch processing happen, where let's say overnight, every 15 days, there's a lot of such things are taken care. Right. So overall, I think we have come up to the IoT platform. I will try to cover up one or two slides on the IoT, the security side of it, and then we will move into the IoT application. Okay, so on the IoT security, again, it's again a big topic, but just we will summarize and we will put some thoughts on that. So as we have seen already, the Internet of Things is nothing but connect the every object to exchange data, provide more comfort, improve the life of people. Connecting object could be car, homes, machine, there's a lot of sensitive data about a user, about a system, about organization, and so on. The sensitivity data means it's not only means for public, but it is also very much protected, right? And a lot of good information security practices and policies are required. So as the number of the IoT solutions are increasing day by day, and then more data is being collected, and more of our let's say a system, or let's say things close to us is getting smarter, there is more risk of being security concern, of being hacking, and so on. So in nutshell, what are the area that we have already covered earlier? If you look at, these are the links. For example, the exchange when it is happening from device to the gateway, that need to be secure. There is an exchange which is happening from the IoT gateway to the platform, that need to be secured. Similarly, like if there is two guys who are talking to each other, that need to be secure, and like the IoT platform and the enterprise and the application. So this is one part of it, but I'm saying, like, in broad sense, these are like different layers of the security that is required on the IoT platform. There's a physical layer security, there is a network layer security, there's access security, application security, and device security. So just to give you some of this glimpse, of course, like we'll not go into more details of it. For example, device security. What do you mean by device security? So the device security is the end device which is deployed into the IoT platform, that need to be secure. If somebody stolen it or somebody try to tamper it, the platform or the whole system should be aware. What we are trying to do, let's say what we are trying to look at it here, just think about the car use case. In case of a vehicle, and if this car data somebody can get access of it, they will know that where you are going. For example, you have started from your home and you are going to your, let's say, your college, for example, or you are going to your city for some shopping and purchase. And if I get an access of your live data, for example your live location, I can easily figure out that where this vehicle is going, right? So it's a huge area, but think on these protocols are means, and these different layers, the securities are required. Okay, so now what we'll do, that we will move into the application layer, application of IoT, and then we will try to cover up little bit on the what are the skill required for the. So we have reached to the last part of the session, and here we will discuss about the IoT various application, as well as we will also help you to look at the skill set which is required for developing an IoT solution, and then finally we will give you some problem where you can work, and then you can communicate with me if you have implemented, or if you're facing any issue. We will certainly try to help you with myself, or like the team members from my organization will help you. Okay, so let's jump quickly into the IoT area. So IoT has expanded into many segments, and right now it's heavily being used into the industrial IoT. The transportation is another area, energy segment where it is used heavily into the oil and gases, and the various other segments. On the consumers, on the home automation, building automation, it is heavily being used. It's IT, asset management, public and grievances, all of these area where it is also being used. In case of healthcare, public safety, whatever you call it, it's like every places this is being used. Let's what we'll do in the next slide, we will cover some of the key area, we'll talk about it, and then finally we will look more how it is being used into the smart cities. Okay, so some of the key area on which this is being used, at least on the Indian perspective as well, the smart home, wearable is another area. The COVID has also extended this wearable segment, where people are trying to innovate in terms of identifying the health of a person with help of wearables. So it could be health band, it could be a smart t-shirt, it could be smart wearables, like anything which can quickly tell you the status of the health of a specific person. Connected car, we have already seen many example during the presentation, but overall this is another prime area where a lot of investments are happening. In multiple domains, in multiple cows, but some of the key areas, of course, one is the autonomous driving. The another thing is basically in US and Europe and other places, they are trying to look at the insurance company is basically trying to look at the data of vehicle, and then the driving pattern of individual or driver. Based on that, they are trying to issue the premium for the insurance and so on. So the guys who are having good behavior, or they are better driver, for them the premium will be reduced, versus the driver who are rash driving, and they take left right turn very quickly, and means abruptly, and then they apply brakes, and like it depends on the various parameters, but think like this is one of the focus area. Industrial IoT, of course, industry is looking forward to automate things day by day, and this COVID is another you can think like a catalyst, where a lot of non automated industries are also looking forward for automation, due to the lack of resources, the lack of the human labor, and then also to increase the efficiency on the production line. They're looking for using the IoT in the industrial solution. Smart city is one of the focus area in Northeast. Also, there are a couple of there's a plan for a couple of the smart cities. IoT in agriculture and the smart farming is another focus area. We'll discuss about this if time permits. A smart retail is another area where people are trying to automate things, which can help to quick checkout of the customers and so on. Energy management is another area. IoT in healthcare is growing rapidly, and with the advent of or let's say in coming of 5G, we are expecting a lot of solutions to be developed in IoT. Smart supply chain. What we'll do on couple of next slide, we'll discuss about one or 2 points, and then basically we'll look at on the skill set which is required to develop similar solution. Okay, so automotive we have discussed, but primarily if you look at how this automotive enabled, so most of the car which is coming nowadays, they come with a diagnostic bus, and this there is a OBD with help of a dongle or a data logger. All of your vehicle sensor is being uploaded to the server, and on the server side there is a lot of processings are happening, and based on that processing the various applications are being developed. Some of the basic thing could be, let's say, geofencing, where if you have a fleet of n number of vehicles, and then you want them to only go to a particular region or a specific city or a specific area of the city, you should be able to set the geofence, and based on that, if they're crossing it, you will get an alert and so on. The next focus area, which is already very much visible in India, at least, and a couple of states like Gujarat, UP, Bangalore, and others, they are looking forward for smart metering in electricity as well as on the water side of it. So, what is the benefit over here? See, currently the whole process is manual. Like, there's somebody who need to come on a end of the month and need to record the bills, record the amount of unit that is consumed, and then finally your bill will be generated, right? Again, if let's say if your account is disconnected due to the non-payment, and you want to reinitiate the connection, right, it is not a straightforward. You need to go and talk to the respective guys, and they will take their own time, and then they will come. So all of these issues can be fixed with help of the smart meter. Again, in the gas side, also there is a smart meter which is coming, where, like, based on your consumption, you will be billed. Water side, at least the cities like Bangalore, they're like good amount of apartments adopting this smart meter, where they are trying to see the consumption based on the usage, and then your bill gets generated only for the unit that you have consumed, and so on. Building automation, this COVID has again motivated a lot of people to do building automation to increase the efficiency and the resource effectiveness, and same time, of course, the manual labor, finding manual labor is difficult. So that problem is being solved with help of an IoT when people are trying to automate. For example, if there's a parking, right, can we automate that parking? There is a let's say visitors who are coming with a vehicle, can we record all of these vehicles, can we detect, and so on. Okay, on the smart city again, so a smart city is nothing but it's an urban area where there's ample amount of sensors and gateways and the controller devices where implant to gather the information and manage the resources and asset more effectively. Okay, so smart cities mission is certainly to drive the economic growth, improve the quality of life, right, and same time with help of technology, right, multiple solution which can benefit the citizen of that cities, right. So we will play a small video over here, and then we will move into the next topic. So look at this video summarize all the benefits or all the area of smart cities. So look at, like, they're talking about the connected street. So for example, somebody is walking based on the lights are being turned on, right. Similarly, there's a parking slot, one person is looking and then he got an info that okay, there is a slot available, you can go and park over that place. Look at the smart dustbin or garbage, where like you can understand what is the amount it has filled, and based on that it can let the departments come to collect it. Yeah, so look at this accident case. Where there's a case, it will just the rescue team has come to recover them, right? So the scope is tremendous in terms of giving the benefits to the citizen, right? So anyway, I think we have covered it up, and now Yeah, so some of the other area of the smart cities where this IoT is being used is, of course, the waste management, water management, energy management, urban mobility. Again, on the public safety, public grievances, addressal, electronic service delivery, engagement, video crime monitoring, where let's say the video systems are there, and with help of the video system, it can figure out the issue in the city. Retail is another area. So I think there's a lot of things. We will not go into the details of it, but think about it that all of these is enabling the smart cities, right? Well equipped, better performance, and so on. Then metering we have already discussed there. Smart parking, right? Smart transportation system, those kind of things are there. In retail, I would like to again play a small video, and this video is basically an Amazon product, and then we can just look at it about it. For example, let me play it. So
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back.
So another thing, it need to be very accurate.
Automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Yeah, so you have seen, let's say this again, just to add here, the solution on the smart retail, which the Amazon Go, it is not possible only with an IoT. You have to certainly look at the real-time processing of data. It need to be very accurate. It has to learn a lot of behavior about the person. Based on that, it can also guide that where he should go to buy the new or the other rest items, and so on. So basically, IoT is an enabler in terms of gathering the data, accumulating it, and so. And now there's a lot of beautiful application that need to develop on top of it. Okay, so there's some of the other areas like telemedicine, teleeducation, and with help of 5G, which is coming, a lot of the telemedicine will happen over the Internet of Things. Smart lighting, smart parking is already, a lot of cities have started using it. In fact, let's say your college campus can also implement that. Then I think there are a couple of videos for the smart cities. You people can just use it, can go through it, and can play it. Anyway, so what I will cover now is the skill which is required for developing a solution on IoT, right? So it's not like the complete list of it, but think like there is a quick area which you can explore and you can understand. So things, typically these are embedded systems, and then you look for more platform dependent coding, like embedded C assembly or similar languages, even Python, C++ are also being used. Gateways are a little more robust, and they are capable of handling the let's say the data which is coming from all of the things, the communication with things, and then on the other side communicating the data back to the platform, getting the information from the platform and delivering back to the sensors or the specific devices and so on. On the platform side, of course, on the backend, Java, microservices, Node, this Python and other Go, a couple of the option people are using it. Data analytics, again on the server side, mostly it's Python is being used. On the edge analytics, Python and C++ both are being used. We'll quickly look into the front-end technologies. Are again, it's very basic like HTML, CSS, JavaScript, jQuery, Node, React, Angular. These are being used. Sorry, I think I should have added some more topic to this, or let's say information, but yeah, I missed that. Then there is a mobile application, typically Android and the iOS. These two exist, but there are also a lot of cross-platform tools and technologies are available, where like people are using that to like develop once and deploy at other two places. On DevOps side, DevOps is again it's like the complete behavior of the solution, the internet based solution has changed, in the sense right now everything is live. So if there is an issue happen, you expect them to be fixed then and there immediately. For example, if you're watching let's say one set-top box, Tata Sky or Airtel or so, and suddenly let's say there is no channel is broadcasted, right? You want to raise and complain, and then you want to quickly fix it. Look at the broadband solution which you have in your home. If it is down, you just take a phone and immediately call that guy, and you are behind him to fix it, right? So all of those somebody need to really look at and can respond quickly if the system is down, and so DevOps is another area which is being developed. So I think that's how we came to an end of the session, but I believe you some of these thoughts to work onto it. So and of course this is the big list I have, but only few of them I've just added it. So one of them is smart alarm. So smart alarm is nothing but the alarm which basically ask you to solve a puzzle, or perform some mathematic operation or something, then only the alarm snoozes, or you should be able to cancel it. Otherwise, like you have a habit that you put an alarm and then what happened, you just turn it off and then you again sleep it, right? ATM monitoring, there's a lot of incidents are happening in the ATM, so can we develop a solution which can basically figure out what's happening in the ATM? So you may use some video analytics based solution, where like you take a stream, process it, and then look at if anything bad has happened. For example, if any unknown has come, or like any guy have come with some arms, then you can easily let the nearby police or the responsible person to update about the current scenario, right? There is a product quality detection system. Think like there is a system which is making some boxes or screws, or let's say some of the component, so that can also be monitored with help of IoT, where you can detect the issue beforehand. Smart classes, I think all of you who are a student and the faculties and the resource person from the college, so you certainly looking forward to more smarter ways, right? Like the smart class system should figure out the person who is coming, should set the context beforehand where the last class was completed and so on, right? So I think with these thing, I want to just leave this to you people, and then you people can design it. You people can reach out to me in case if you face any issue while implementing it, or you need some assistance. We will be certainly providing it. It may not be means in real time, but certainly we will reach out to you once we get a notification or mail from you, right? So anyway, I just told you some of these things which you can look at, and yeah. So smart classes, probably like we can get rid of the manual attendance, feedback about the course, faculty, student, that can be taken quickly from the system itself. System should be context aware. We should know that what was the last context on which this class was ended, and so on. So I think that's all. So if you have any question, you can now type it into the window, or like you can communicate it through the coordinator of your college, and I am here to answer them, right? Anybody who would like to keep the address there, you can use it. You can store the email ID and you can reach out to me. Thanks. So now I will be taking the Q&A. Thank you.
Dear participants, we have now drawn to the close of the first session. We would like to request you to kindly join us for the second session at 3 p.m. on Google Meet. The link to the meeting has been shared on the WhatsApp group of the webinar, so kindly check the group for further details. The second session is an interaction session with the speaker, where you will get to post your questions and have them answered by the speaker, so kindly be ready with the questions that you wish to ask. Also, at the end of the session, we will be sharing a feedback form for you to fill. I would like to mention that filling up of the feedback form is mandatory for you to get a certificate. Thank you so much for being a part of this session, and we hope you enjoyed the session, and see you at 3 p.m.